Eibos has just launched their Tetras filament dryer module upgrade to the Bambu Lab AMS, or Automatic Material System. So let's take a first look at it, as well as compare its features to the Bambu Lab recently launched AMS 2 Pro. Let's find out when it makes sense to buy the Eibos Tetras upgrade versus buying the Bambu Lab AMS 2 Pro and vice versa. Hi, this is Ken of Wrist Innovations, and I'm excited to share with you my first look at Eibos' new Tetras filament dryer, which is an upgrade to the existing Bambu Lab AMS filament unit, which Eibos just launched this past weekend. I want to thank Eibos for sending me a beta version of their Tetras filament dryer upgrade module for my evaluations. So, what is the Tetras? It's an upgrade module designed to be installed on an existing Bambu Lab AMS unit that offers independent filament drying parameters for each of the 4 filament spools within the AMS. It's easily mounted on the AMS and it operates independently of the AMS. So, it has its own power supply, controls, and user interface. Since it operates independently from the AMS, any Bambu Lab firmware changes have no impact on the operation of the Tetras. So now, let's dig into the features of the Tetras and compare it to the Bambu Lab AMS 2 Pro. Number 1, the Tetras upgrade module is easily installed on the Bambu Lab AMS unit within 30 minutes with no irreversible modifications to the AMS. Number 2, it's a matter of removing the lid from the existing AMS and replacing it with the Tetras lid that has 4 independent controllers that provide individual heating and drying of each spool of filament inside the AMS. I'll go into the details of the installation in the next section of this video. Number 3, the Tetras has an automated fan and venting for each of the 4 chambers to allow moisture to be removed from the Tetras AMS system. Number 4, the Tetras has its own power supply and a user interface, so it is completely independent of the Bambu Lab AMS. Number 5, the Tetras also has a second stage drying function that allows you to continue to dry your filaments while you are printing with your Bambu Lab printer. If you need a special part made and you don't have the capability in-house, I have the answer for you. This brings me to the sponsor of today's video, PCBWay. PCBWay is a great resource for PCBs, CNC machining, sheet metal fabrication, injection molding, and various 3D printing, including metal printing. I have personally used their services to 3D print a stainless steel insert for my external spool Y-splitter insert. The stainless steel will ensure it will never wear out from constant use. I went on their website, uploaded my Y-splitter insert design, selected stainless steel and quantity, and I received an instant quote. Then, after their engineering team reviewed and approved the quote, and they received my payment, they manufactured the parts and shipped them right to my door. Their customer service and quality of parts is excellent. Give them a try by using my affiliate link below. Now, back to the show. Number 6, the Tetras automatically switches to the humidity mode after drying to maintain a preset relative humidity environment. Number 7, it also has an unlimited drying time option. Number 8, the Tetras user interface allows you to choose a preset setting of drying conditions for PLA, PETG, TPU, and ABS, as well as 2 custom preset settings that you can set yourself. Number 9, the Tetras has a maximum temperature of 65 degrees C and a drying time from 30 minutes to 24 hours. Number 10, it also has 3 drying power modes, low, medium, and high. So now let's compare the Tetras features to the Bambu Lab AMS 2 Pro. Number 1, they both have a maximum temperature setting of 65 degrees C. Number 2, they both have automatic venting and sealing of the chamber. Number 3, the Tetras allows you to continue to dry filaments while you are printing. However, the AMS 2 Pro does not allow this at this time. Number 4, the Tetras has 4 chambers within the AMS that allow you to dry different materials at the same time. But the AMS 2 Pro only can dry one type of material at a time because it is all one chamber. For the Tetras, you could dry PLA in position number 1 at 50 degrees C and dry ABS in position number 2 at 60 degrees C at the same time. Of course, the individual chambers are not airtight within each other, so there will be some heat transfer between the filament positions. I did a brief test where I loaded PLA into positions 1 and 3 and ABS into positions 2 and 4. I used the Tetras presettings for PLA of 50 degrees C for 4 hours and for ABS 60 degrees C for 2 hours. I was curious to see how the different temperature set points affected each chamber because the chambers are not airtight, especially since the left desiccant chamber has a common path between chambers 1 and 2 and the right desiccant chamber has a common path between chambers 3 and 4. It took about 20 minutes for the PLA chambers to reach their set point of 50 degrees C, and it took about 30 minutes for the ABS chambers to reach their set point of 60 degrees C. And it only took about 15 to 20 minutes for the relative humidity to reach the target of 10% for all 4 chambers. All the chambers' temperatures and relative humidity remained constant for the remaining 1.5 hours. So it appears to me that having different materials in the chambers at different set points did not prevent the individual chambers from maintaining their desired set points. For instance, the PLA chamber did not overheat due to the higher temperature ABS filament in the adjacent chamber, and the lower temperature PLA did not prevent the ABS from maintaining its higher set point temperature. After the first 15 minutes of operation, the relative humidity remained at the target 10% for the balance of the hour and 45 minutes of the test. After the ABS 2-hour drying cycle completed, the Tetras switched to a 10% relative humidity mode, and after an additional 60 minutes, vents for the 2 ABS chambers automatically closed. The Tetras and the AMS2 Pro use similar techniques to evenly heat the filaments. The Tetras has heaters and circulating fans that move the air throughout individual chambers. The AMS2 Pro has heaters and 2 fans that circulate the air throughout the AMS. However, it is only 1 cavity for all 4 spools. The AMS2 Pro also uses motors in the AMS to rotate the spools for additional even circulation. Ironically, the first time I saw the concept of rotating spools within a filament dryer was when I saw the Eibos polyphemus filament dryer. I published a video on testing the Eibos polyphemus and 2 other manufacturers' filament dryers, and that link is in the description below. Both the Tetras and the AMS2 Pro dry the following filaments: PLA, PETG, ABS, ASA, PET, PA, and PC. TPU is a bit tricky. The Tetras is capable of drying the TPU, but once it's dried, it will need to be removed from the AMS for printing because the AMS is not capable of printing TPU because it's so flexible. On the other hand, the AMS2 Pro can't dry the TPU because it isn't capable of printing the TPU. Neither the Tetras nor the AMS2 Pro can dry the higher temperature materials, especially the glass-filled or carbon-filled materials. Now, let's see what is involved with installing the Tetras upgrade to the AMS. It took me about 30 minutes to install the Tetras upgrade to one of my existing AMS units. First, I removed the lid from my AMS. Eibos provided a long hex head screwdriver, which was needed to get to the lid screws. Then I installed the main Tetras lid assembly to the AMS. Then I flipped the AMS over and then installed the elevated feet and 4 cable assemblies. After that, I installed the power module and screen module to the elevated feet and connected the 4 cable assemblies to the 2 modules. I added 8 small rubber feet to the bottom and then flipped the unit upright. Then I opened the lid and installed the front, middle, and rear baffles. Next, I installed a rubber gasket in the back near the hinge area and plugged the power cord into the outlet. I pressed the power buttons on the 4 screens and I chose my preset filament settings. So now let's talk cost. At the making of this video, June of 2025, the Tetras AMS upgrade module is on sale at a pre-order price of $179, normally $199. The cost of the AMS2 Pro is $359, plus a $33 for a power adapter if you'll be drying filaments when it is hooked up to a P1 or X1 series printer. In my opinion, the Tetras is for people that already have original AMS units for their P1 series or X1 series of printers, and they want to add a drying function to their AMS units. A standalone 4-spool filament dryer from Sunlu costs about $140. So, if you're in a tight space, you can modify your existing AMS with the Eibos Tetras for only $40 more and have it function as your filament dryer and your AMS filament delivery system. For anyone wanting to add an AMS to their P1 series or X1 series or H2D printers, the best solution would be to buy the AMS2 Pro at $392. It wouldn't be the best value to me to buy an AMS at $319 and add a Tetras upgrade at $179 for a total cost of $498. This has been a brief look at the Eibos Tetras AMS upgrade to your filament drying capabilities for your existing Bambu Lab AMS units. The Tetras has some unique features, such as being able to dry different materials at different temperature settings at the same time due to their 4 individual chambers and heating controls. The Tetras also allows you to continue to dry your filaments while printing, so that is a nice feature. Also, since it's completely independent of the AMS unit, it's not affected by Bambu Lab firmware updates. The Tetras brings some nice features to anyone who already owns an AMS and wants to add drying capabilities to their AMS. But for anyone who wants to add AMS capabilities to their existing P1 or X1 series printers, the most economical option would be to buy the AMS2 Pro at $392 versus buying an AMS at $319 and the Tetras at $179 for a total cost of $498. If you want to see my video titled, "Do you really need a filament dryer for your 3D printing?" that link is here. If you'd like to see my video titled, "Which is the best brand of PLA filament for 3D printing?" that link is here. Thanks for watching. Bye!